Hello, welcome to The Naked Scientist with me, Chris Smith, and also with Kat Arney.
Hello, today we'll be looking at breakthroughs in the science of sleep, why teenagers should be allowed a lie-in, how soldiers survive on just 4 hours sleep, and what do you say in your sleep?
Vampire penguins and zombie guinea pigs. We're done for.
We hear from one very prolific somniloquist.
Plus, news that the missing Beagle 2 probe lost on Mars a decade ago has been discovered, why the ingredients for life on Earth could have been cooked up in comets by UV light, and why a computer probably knows you better than even your friends do.
The Naked Scientist podcast is powered by ukfast.co.uk.
The history books will need to be rewritten because 12 years after it vanished without trace during its descent to the surface of Mars, the Beagle 2 lander has been found. The probe was presumed to have crashed and been destroyed, but high-resolution images from a NASA orbiter have revealed that it did make it to the surface of the planet after all.
Greta Jackson has been following up on the story. She's with us now.
Yes, it's certainly an exciting discovery. I caught up first with UCL's Andrew Coates, who helped to build and launch the bowl-shaped probe back in 2003.
The mission that Beagle was supposed to do was to be a lander to go to Mars, to land on the surface, look for signs of life on Mars. And so there were a number of different instruments on board to help with that, including imagers, but also X-ray fluorescence and other techniques of analysis. But it was just a fantastic project to be involved with. Successful launch, of course, in 2003, and we were all so excited about the possibility of not only getting into orbit around Mars with the Mars Express orbiter, but getting to the surface as well.
This would have been the first UK-led mission to set foot on Mars, but sadly, it was not to be. Here's a clip from the late Colin Pillinger, the probe's principal investigator, at a press conference.
Unfortunately, we don't have any Beagle data in the telemetry for this pass, but they haven't yet checked whether the radio signal was working, but they don't have any reason to believe that it wasn't working.
You worried?
Not yet.
Beagle 2 was transported to the Red Planet by the European Space Agency's Mars Express orbiter. It successfully launched the probe on Christmas Day of 2003 and even sent back a picture of Beagle 2 receding into the distance and down to the dusty Martian surface. What happened was a complete mystery. Judith Pillinger, one of the Beagle team.
It would have been convenient if we'd have got a signal at the first opportunity. Everyone could have clapped and gone home and enjoyed a happy Christmas. As it is, people have to hang around a bit longer and come back for more of the same.
But on Friday, NASA's Mars Reconnaissance Orbiter snapped a picture of what is believed to be the Beagle 2 lander. I asked Andrew Coates how he felt about this extraordinary news.
Really excited. I mean, it's just amazing. It's like a long lost friend, really, because on Christmas Day in 2003, there we were waiting for the data to come back. Unfortunately, it didn't come. So now it really provides some closure, actually, having seen this shape which looks like Beagle on the surface.
Do we know what happened?
Not 100%. There are many things which could go wrong. There's about 75 different things in the sort of sequence from the top of the atmosphere going through the heat shield, and then the parachute deployment, and then finally the airbags dropping onto the surface, being the right way up, and the solar panels deploying. So all that is a sort of simplified sequence of what was really several minutes of terror, as NASA would say, as we waited for the thing to actually work.
Is there any opportunity for a quick fix? Curiosity could perhaps come on over and fix it?
Curiosity is much too far away, but one possibility which we could consider, of course, is suggesting that the ExoMars landing site is actually somewhere near, and we pile some jump leads on to go and kickstart the thing. But it would be a dream to actually go and see what's happened to it, or maybe just tip open that final 1 or 2 solar panels and have it transmit.
So it could have actually collected some data.
Yeah, that's the possibility, because it got far enough that 2 of the solar panels, at least, possibly 3, deployed, and of course it had battery power anyway, which was left over from being charged on the Mars Express orbiter before it was separated. So there would have been enough charge, and the computer would have started, and so on. So the pop-up mirror would have popped up. So with that, the idea was we'd be able to see a panorama, including the horizon of Mars.
Sounds like a beautiful image. What sort of lessons are to be learned here?
Well, there are a number of lessons to be learned. First of all, you wouldn't necessarily build it in the same way. It was really critical that, everything was sort of packed in like a pocket watch, if you can imagine that. And we don't know exactly why it didn't deploy completely. But what we do know is that the entry, descent and landing all worked. So, historically, this makes this really important because only Russia, with the first landing on Mars, Mars 3, which landed and sent back data back for about 15 seconds or something like that. And then the Americans with their various landers on Mars, starting with Viking and going on through, up to Curiosity. So there's Russia, America, and now the UK and Europe have landed on Mars successfully. It's a soft landing. The only thing which didn't happen was unfortunately transmitting information from the surface.
I feel like the UK and the EU deserve a pat on the back.
Absolutely, yeah. So, it makes us really proud to be from the UK, from Europe, and of course, Colin Pillinger with a vision to put this together, because of course it was his vision to actually have such a lander on Mars Express. And I have to say, the Mars Express orbiter has been very successful over, in the over 10 years it's been in orbit around Mars. So Beagle's place in history is really assured.
UCL's Andrew Coates there.
And in fact has history for us too, because both Colin Pillinger and Andrew Coates are on this programme, going back to the time when they made that lander. And it was one of the first interviews that you did on The Naked Scientist, wasn't it?
It was. I got sent along, I think it was in Camden, and I got sent along with my little mini disc recorder. So that's showing how old it is. And there's hope for everyone who wants to be a broadcast journalist, because it was a terrible interview, and here I am today.
12 years later. Thank you, Kat. Now, how well does your best friend know you? And how do you think their judgment of you would compare with what a computer would conclude? Well, new research out this week in the journal PNAS says that the computer would probably win. Cambridge scientist David Stilwell has created a computer program that can use the things that you like on Facebook to make detailed personality judgments. Interestingly, as few as 10 likes provide a more accurate picture of you than a work colleague can. David's with us to tell us how it works. Hello, David.
Hello.
Well, how did you do this study?
Well, this is the combination of about 8 years research. So in July 2007, we put a test on the Facebook social network and got people to take the personality test and then get feedback on the results. And as part of that, they could opt in to share their Facebook likes. So over the past 2 or 3 years, we've been interested in how accurately can we predict someone's personality just from their Facebook likes.
In other words, by trawling across a lot of data about what people self-select to say that they have a liking for, then you're able to draw conclusions about what sorts of things in general would be true of that particular person.
Exactly. So there are about 100 billion things that people can like on Facebook. So they've got a massive choice to choose from. And on average, people like about 220 different things.
Do you have to be a very prolific user of Facebook for you to get an accurate appraisal?
Well, given an average number of Facebook likes, the computer is actually as accurate as someone's spouse at understanding their personality. So that's more accurate than their family, more accurate than their friends, and far more accurate than their work colleagues.
When you say you know them better than their spouse, what sorts of things can you say you know?
Well, so this is based on the self-report questionnaire that people did. So we measured 5 traits in the self-report, and these are the so-called big 5 personality traits. It's quite broad factors such as how extroverted you are, how open to new experiences, or how sort of agreeable, so that means interested in social welfare versus quite competitive.
Are there wider implications and uses of this?
So the immediate implications are for personalizing people's online experience, so deciding which adverts you view and hopefully making those adverts more relevant and more interesting to you. So that's not just selling you different things, but also selling you the same things in different ways. So let's say I'm interested in charities. So if I view a charity website, if I'm a very conscientious person, so interested in sort of numbers and statistics, then the charity could give me more information about what the charity is doing. If I'm a more emotional person, then the charity could tell me stories and show me pictures. So the same thing is being sold, but in different ways.
What's really new about this, though, David? Because is this not pretty much what credit card companies have been doing by watching what I buy, where I buy it and when I buy it for decades to build up a profile knowing more about my purchasing habits than I do?
Well, I mean, what's different about predicting personality as opposed to just correlating people who buy this also buy that? And what's different about personality is, as I say, you can sell the same thing in different ways. And you can also get an understanding of, what is this person that I'm selling to? So, I mean, for me, it's more of a throwback to the past. In the past, you used to go to a shop and the shopkeeper would treat you like an individual person and would sell to you as an individual, knowing your psychology. When the internet came along, that kind of went away, and in the name of efficiency, we gave everyone the same experience. But now we can go back to kind of the possibility of treating people like individuals rather than just numbers.
And lastly, how does this go down with consumers? Do people think this is a good idea, or are people concerned?
Well, I personally find it quite creepy that it's possible to make these predictions. I think
You invented it.
It's not just my predictions, but even the other predictions that are being made. And I think the reason I find them creepy is that I don't understand why I'm seeing the things I do online. So Facebook showing me adverts, Google showing me adverts, lots of companies are showing me things, and I don't understand what data they're using behind the scenes to make those predictions. And that doesn't have to be the case. A company could say, they show me an advert and it could say, you're seeing this because you're an extroverted person or because you're well organized.
David, thank you very much. David Stillwell. We'll look out for what we like on Facebook in future a bit more carefully.
You are listening to The Naked Scientists with Chris Smith and with Kat Arney. Coming up, signs that the building blocks of life might have formed in ice clouds in outer space, and also the latest breakthroughs in the science of sleep. Stay tuned to hear about how to control your dreams, why you sleep talk, and what happens when you don't get enough.
Before that, though, it's a fact that more boys than girls pursue STEM careers. That's careers in science, technology, engineering and maths. To date, researchers have come up with all kinds of explanations as to why this might be the case, and these include inflexible working hours or a reluctance to enter the cutthroat competitiveness of certain fields.
But now a report from Princeton University suggests that it's the idea of innate brilliance which contributes most to the disparity between the numbers of men and women in science subjects. In other words, it may all be down to how people perceive a subject. To find out more, I spoke to Ellie Cosgrave, an engineering researcher at UCL and founder of Science Girl, an organisation that aims to encourage girls into fields like maths and physics.
This report looked at whether the expectations of brilliance underlie gender representation in certain fields, particularly looking at the gender diversity in STEM subjects, which is science, technology, engineering and maths subjects.
So in this study, they talk a lot about brilliance and the role of brilliance in different fields of science and how that influences whether there are more men or women in that. What were they looking at and what did they find?
So the essential idea was that there are stereotypes where it's seen that men have this innate ability of brilliance. I'm innately excellent. And what this study found was that in fields that valued this idea of brilliance are the fields where that have very small representations of women.
What kind of fields are we talking about here? Is it sort of the maths and the physics of this world that you need to be brilliant?
Yes, and engineering.
And certainly when I look around, we've had 2 films coming out about Alan Turing, about Stephen Hawking. If you think of a scientist, I'm sure most people would say Einstein. If you think of the philosopher, I think, German guys with big beards, people like Karl Marx, Wittgenstein, that kind of thing. When you think of a woman scientist, I'm a biologist, so I immediately think of someone like Barbara McClintock, who probably no one's heard of, or
Absolutely.
Marie Curie in
Marie
physics
Curie
and chemistry.
is the big one. We did a survey a couple of years ago when we launched a report about access to STEM careers, and we found that most people couldn't name a female scientist. Of those who could, most of them named Marie Curie, and of those who could, a lot of them named Isambard Kingdom Brunel, which was a male engineer. So I'm not really sure what's going on there with the psyche of our British public.
So there's one idea here that to succeed in a field like maths, like physics, like philosophy, you need to be brilliant, and only men can be brilliant and not women. But also it says something maybe about people's perception of fields, that biology maybe isn't that hard. I find that quite offensive as a biologist.
Absolutely. Really, we need to start tackling these issues at their core, and that means that we need to start tackling issues around what these subjects actually mean, because when you're coming from outside a subject, it's very difficult to know what it means. A lot of people, when I say I'm an engineer, have no idea what that actually means for my kind of day-to-day life. So
do you dig tunnels?
I don't dig tunnels. I like tunnels. It's something that we need to start really breaking down and talking about actually what these subjects are, what they mean, and what kind of skills you need to achieve them. I think it's all of our responsibilities. Of course, there's a responsibility for government leadership in terms of putting standards on advertising, education standards, putting resources out, really showing what science and engineering careers might be like. But actually we have a personal responsibility with every girl and boy that we meet as well, with our children and our families, to show them how brilliant they can be, and not based on their gender, but based on who they are as people. And if we can do that, then I think we can really start breaking down in a really systematic and sustainable way the hurdles that we are putting up for our young people. Anyone can be anything. Let's tell girls that they're brilliant too.
The absolutely brilliant science girl's Ellie Cosgrave.
Life here on Earth depends on a range of complex chemicals, including sugars that are used in genetic material like DNA and its simpler relative, RNA. But it's always been a mystery how these molecules got here in the first place. A brand new study by scientists in France suggests that if chemicals contained in ice particles are zapped with ultraviolet rays from nearby newly formed stars, this can kickstart the creation of much more complex life-essential molecules like sugars. Helen Fraser is a space scientist and an astrochemist at the Open University.
Astrochemistry is the study of where molecules come from in space, how they're formed during the process of star and planet formation. What we see as a byproduct of star formation is loads of molecules forming. Carbon monoxide, carbon dioxide, water, methanol, ethanol. They're very, very common in star-forming regions. And what's interesting about star-forming regions is they're very cold. About minus 263 degrees centigrade, so very cold. And so what happens is these molecules are not in gas, but they're actually frozen out, and they form what we call astronomical ices.
Would the theory then be that some of these things form in space, drift around as these ices, and then somehow land on a newborn planet, like the early Earth, for example, where they could bring the raw ingredients to make complicated processes like the life process get going?
Sort of, yes. What basically is happening is when the star is actually forming, there's a huge cloud of gas and dust around it. And in that cloud of gas and dust, these ices, these molecules, undergo a lot of processing. They're affected by the starlight from the new star, which is ultraviolet light. They also get affected by heat. And one of the interesting things is all this dust and ice eventually is also the material that forms sort of the baby planets, the comets, the asteroids, and eventually the planets themselves. So whatever kind of chemistry is locked up in those small particles is also the chemistry which gives us the naked ingredients which can be delivered to the planets.
And where does this new paper shed light on that process?
Well, what these guys are actually trying to do is they're trying to recreate that process of how the chemistry is happening in a star-forming region in the lab. They try and recreate the low pressure and low temperature conditions in a star-forming region, and then they grow a model of this interstellar ice, this solid material that's made of carbon, hydrogen, oxygen and nitrogen. And then what they do is they shine a light on it, and this light is essentially an ultraviolet light simulating what the starlight is doing. And when this hits the ices, it basically stimulates lots of different chemical reactions. And then you warm the ice up as if the star is warmed up, and the ice appears to disappear. But what's left behind in the experiment is actually what we call technically in the field yellow gunk. So we know from work that was done about 12 or 14 years ago that inside that yellow gunk there are some amino acids. What this paper's showing is that also inside that yellow gunk there are sugar type molecules and sugars, and they're also of biological interest.
What are the sugars and why might they be important?
The sugars that are actually here are glycoaldehyde and glyceraldehyde. And both of these sugars are very important in terms of synthesis of RNA.
This is a form of genetic material, isn't it?
Yes, which comes before DNA. So one of the key propositions in terms of evolution of prebiotic life is that first of all we have what we call an RNA world, which is dominated by this material, and then we move to a DNA type world that we expect to see now. So if you like, sugars are even the step before that. They're required to make that next synthetic step in the biology.
When they analysed the material, can they be reasonably confident that what they think their analyser is saying is in there is what's really in there? In other words, when you do the chemical tests on the yellow gunge and it says there are these sugars there, is it possible that you've actually changed the chemicals in the course of doing the experiment to test for them?
Well, this is a really good question, and actually is part of the reason why there's some controversy around this and experiments like this. So what they do is actually dissolve the yellow gunk in some liquid. Now, it's a little bit like dissolving sugar in a cup of tea, but rather than using hot water, you often use an acidic material. It can sometimes lead to different kinds of chemistries. It's a little bit hard from this paper to know how much that's adjusted the chemistry. And so I think time will tell on that one. That will be an interesting debate for the community to have, whether these very complicated sugars are really absolutely there or also a product of the analysis step.
We wait and see. That was the Open University's Helen Fraser.
You are listening to The Naked Scientist with me, Kat Arney, and also Chris Smith. On to our main topic for this week, and we're taking a trip to the wonderful land of Nod.
We all have a vague notion of what sleep is, but that doesn't mean that defining this mysterious part of our lives is at all simple. Scientists know that we require various types and depths of sleep, all in different amounts and at different times over the course of the average night, but no one knows exactly why. For example, there's non-REM sleep and REM sleep. Now, REM stands for rapid eye movement, whilst non-REM is non-rapid eye movement. This makes up about 75% of our sleep, and there are normally about 3 different stages to it, but it's generally defined by deep or slow wave sleep. REM sleep, on the other hand, is a lighter form of sleep, and that's characterised by dreaming and also bodily movement, and it normally happens towards the end of a good night's rest. So this week, we're examining the breakthroughs in the science of sleep, and we'll be talking to sleep talkers, lucid dream experts, and also a psychologist who's looking to reduce soldiers' sleep time by up to half. Plus, we'll be hearing about the potentially dangerous effects of what happens when we don't get enough sleep.
But first, when and how long should we sleep for? We're all told to make sure we get a good 8 hours kip every night to stay healthy, but research suggests that when and how long we sleep changes with age. So should we be adapting our lifestyle to suit our sleep needs? Colin Espy is Professor of Sleep Medicine at the University of Oxford, and he's spearheading a groundbreaking study that will mean tens of thousands of teenagers will start school an hour or two later to see if more time in bed and a later start time for their classes might improve their exam results. I spoke to him about the experiment and began by asking how our sleep needs change throughout our lives.
I think a way of thinking about sleep across the lifetime is that it's kind of titrated or adjusted to meet the developing needs of the individual. So the newborn baby needs A, a lot of sleep, and B, a lot of particular types of sleep. For example, a lot of slow wave sleep for growth, a lot of REM sleep, rapid eye movement sleep, because of the coding of all the new learning that's happening. But of course your learning continues throughout your life, but it doesn't accelerate the way it is when you're born, so you don't need so much sleep. We know that by the time you go to school, you're no longer napping during the day. At least your primary school teacher wouldn't appreciate it, whereas your nursery teacher's okay with it. So there's another change, that sleep becomes consolidated into the nighttime period. And of course then we have the teenagers, don't we, who seem to be defying their parents, say, I'm not sleepy, and then they're sleepy in the morning. And we know that just as there are other developmental changes, sleep is affected, and not just sleep, but your circadian rhythm.
But of course, they have to get up and go to school. Tell me about the study that you're doing to maybe try and help them out a bit.
We want to test the hypothesis that a later school start time will pay dividends to the learning of the young person, as evidenced by better school leaving qualifications. Now that is a big ambition. But there's good, biological reasons that if teenagers are learning at a more optimal circadian time, that they will do better. But that's just one arm of the study. We want to test that with another element, which is a sleep education program. Often sleep is missed off the agenda. We talk about nutritional needs, we talk about exercise needs at school, but not much about sleep. So we want to help work with teachers to develop a curriculum on sleep for schools. So these two elements we will test separately and together in this trial, and then the fourth arm of the study will just be as things are at the moment. And by having this design, we should be in the best position to tease out what is most effective.
Do you have any idea of what kind of improvement you might be hoping for? Is this the difference between an A grade and a C grade?
That's a very good question, and I wouldn't like to anticipate exactly what the level of difference should be, because there will be some people will be markedly helped by this, one would anticipate, and others less so. And then you end up with an average statistic. It's a bit akin to an intervention that you can use at a public health level. So what we're trying to do is, if you like, shift the whole population curve in terms of its performance. And within that shift, there'll be some people who've benefited more and other people's a bit less. But we don't think it'll do harm to anyone. If you ask any teenager, I think they'd be enthusiastic about this study.
I'm sure they would. That's Oxford's Colin Espy. And the results of his study will be published in 2018. So we'll have to sleep on it for now.
I don't know about teenagers. I'm enthusiastic. I'd like to join that trial, actually. I think I would benefit from an extra hour in bed or two.
Absolutely.
We're talking being in bed every night. Each and every one of us has, on average, 5 dreams, and they last between 15 and 40 minutes. They can be exciting, frightening, funny, and sometimes totally mad. But are they random, or can we control what we dream about? Well, Tim Post is an expert in the art of so-called lucid dreaming, and he actually teaches a course on how you can control what crops up in your dreams. He's with us now. Hello, Tim.
Hello. Hi.
Tell us first, Tim, what actually is going on in your brain when we dream, and why do we do it?
Well, that's a big question, actually. It's actually a kind of like a collaboration of the brain. So the entire brain is involved with generating our dream experiences, and there's a bit of a subconscious process that is creating our dreams, but there's also a conscious process, and it's that conscious process that we can actually control as lucid dreamers to reshape our dreams and dream about anything that we can imagine while we are dreaming, and that is lucid dreaming.
If you look at what the brain is doing and how active it is or not when we're dreaming, is sleep a static thing? Are we at the same level of brain activity all the way through the night, or are there peaks and troughs in what the brain's doing, and where does dreaming fit into that?
So we go through the sleep cycle. So we go through deeper sleep stages, and then gradually our brain becomes more activated and seeps into REM sleep, rapid eye movement sleep. And because our brain is more activated during REM sleep is also referred to as paradoxical sleep, in a sense that when you look from the outside in and you see someone being asleep in REM sleep, you say, well, he's resting and looks quite peaceful. But if you would actually take a look at the brain in REM sleep, our brain is highly activated. So REM sleep has much more to do with activation and learning rather than resting and peacefully lying.
And how does one set about manipulating that process and that activity in order to direct what our dreams do?
If you know as a lucid dreamer, while you're aware of your dreams and you're still dreaming, you know that actually part of the dream generation process is governed by your own thoughts and reflections while you are dreaming. You could then very simply refocus your thoughts and intentions and reshape the entire dream. So, for example, if you're dreaming and you would like to fly like Superman, for example, you could just initiate certain expectations and feelings that are accompanying that Superman flight. Just so kind of refocusing your intentions as a lucid dreamer. And by doing so, reshape the entire dream and then notice that you will be able to fly or do whatever you like.
Is this something that you do before you actually go to sleep? Do you actually put yourself in a certain mindset which then elicits that behaviour once you're asleep? Or is it more about training your thought processes so that you can control them once you're asleep?
Well, that's a good question. Lucid dreaming is not like something called dream incubation, where you, before you go to sleep, think very hard on a particular theme, like, for example, the Superman dream, and then you're hoping to dream about that Superman flight once you wake up the following morning and then realize, oh, I just dreamed about being Superman. As a lucid dreamer, what actually happens is you recognize that you are dreaming while you are still in the dream, like, aha, this is a dream. And actually now I know that I'm actually lying in bed asleep with my eyes closed. And in that kind of present moment, you can then take control and initiate any kind of lucid dream that you desire, for example, flying or whatever. So it's a much more conscious, live, on-the-fly kind of happening.
Can anyone do this?
Well, pretty much anyone can learn to become lucid. It requires a certain level of dedication and discipline to apply various techniques. Also, you need to be able to sleep for at least, well, let's say 8 hours or so, because otherwise if you are limited in your sleep time, you wouldn't generate that much REM sleep, that stage where lucid dreams are also happening, and that will decrease your chances of becoming lucid. So those are the main requirements, and well, from that anyone can learn to become a lucid dreamer, yeah.
Do you think you really do control your dreams?
Well, there are various scientific studies that have been conducted to experiment with this issue, you could say. Lucid dreamers were assigned as research subjects to carry out particular predetermined tasks in their lucid dreams. For example, making eye signals. Through that, we know for certain that, well, control is real. And in that sense, lucid dreamers can do whatever they like to do in their dreams.
Well, in my lucid dream tonight, I'm going to make loads of money and then make the best radio programme in the world from the best studio I've paid to build in the world.
Awesome.
Tim Post, the founder of Snoozon, thank you very, very much.
Thank you.
Kat.
So that's dreaming, but what about sleep talking? Almost all of us have at some point been told that we were talking in our sleep the night before. Nothing too embarrassing, I hope. There's that niggling worry that we've blabbed some deep subconscious desire of which we are normally unaware. Greer Jackson, professed sleep talker and sleepwalker, wanted to understand why we sleep talk and whether there's any hidden truth behind the babble. She spoke to Karen Slavik-Leonard, whose husband Adam went through a phase of prolific sleep talking, or to give it its medical name, somniloquy. Karen even recorded Adam's sleep talking and put them on a blog.
It sort of started slowly. It went like a bell curve. You know, the more amused I was, the more often he did it. And we did get to a point at the pinnacle of his career where Adam was saying many times a night, nearly every night.
I asked Karen to pick out some of her favourites, but she said there were just too many to choose from. Instead, we opted to pick one recording from each category, of which there seemed to be 3. There's the horrendous insults, most of which I couldn't possibly play on the air, but there is this one about vegetarians.
You know, the world will be a much better place when we get to eat vegetarians. You'll get your 5 a day with one of those.
Incidentally, Adam has nothing against vegetarians when conscious. The next topic falls into the bracket of how amazing he really is.
Here's my CV. Why don't you just file it under awesome?
And then there's the absurdly random.
Jellyfish are attacking. Everybody grab your ice cream guns.
They're just classic. I feel like they're things that you can't even write. They're so random.
Well, and that's the thing, is that awake Adam could never come up with these things. People often ask why I think he came and then why he went. And I can only ever theorize about that. But what I think is that at this time in our lives, we were under extraordinary stresses. We were having visa problems. Adam was having trouble finding an appropriate job, and I couldn't work because I was a visitor in the UK. And we were in a very painful and difficult battle for visitation with his kids in court, and we were in and out of court. So we were under extraordinary stress, and that's when Adam started talking in his sleep. And what I think is that Sleep Talking Man just became this really healthy way for Adam to churn through all of this anxiety and sort of spit it out in a funny, healthy way, and in a way that was really well received. I found every single thing he said totally delightful. I never once minded being woken up. I never got enough of Sleep Talking Man, and I miss him terribly. I really do miss him.
Where could Sleep Talking Man have gone? And why did he come and go in the first place? These are questions I put to Dr. Ian Smith, Director of the Sleep Unit at Papworth Hospital in Cambridgeshire. But first, why do we sleep talk?
So we don't know why people sleep talk. It seems to be an inherited condition, and it's very closely linked with sleepwalking. And these conditions usually only happen in a particular phase of sleep, which is very deep sleep.
So I'm a sleep talker and a sleepwalker, but I don't sleepwalk and talk every night. So is there a certain trigger that might be happening during the day that triggers me some nights but not others?
Well, different people have different triggers. Most people are more likely to have one of these episodes if they're stressed. For other people, it will be a noise. Then they'll start doing their automatic behaviour, the talking or the walking. For other people, it's more likely if they are sleep deprived. So if they're very sleepy, then it's more likely to happen.
And is this something you might take someone into a lab for sleep talking and walking if it really was that disruptive in their night cycle, but also, I guess, for their partner, perhaps?
So yes, we see quite a lot of people in the sleep laboratory because sometimes they are associated with quite violent behaviour where people are acting as if they're defending themselves, but they are striking their partner or kicking out. And sometimes it's not absolutely clear that it is straightforward sleepwalking or talking. There are other things that happen in sleep. People can have epileptic phenomena, so it's important to differentiate them and make sure that we are identifying the people with simple sleepwalking and talking where we can reassure them. The other conditions, we may need to investigate them further and consider medication.
Investigating patients further involves a night at the sleep lab. Ian gave me a tour.
There are 6 rooms.
Mm-hmm.
And we try and make it halfway house between a hospital environment and a home environment.
And it does actually look pretty comfortable. It's bigger than a single bed. It's much bigger than my bed at home. Much more comfortable. And you've even got a TV and a sink and a little sofa as well.
Yeah. And the patients will come in the evening and we wire them up. And if you can see at the end of the bed there, the complex electronics are then attached. We record brain activity from electrodes on the scalp and eye movements with electrodes on the eyes, because one of the things we're trying to work out is when they're dreaming, we need to record rapid eye movements. We do that by recording from the muscles around the eyes. We measure breathing, because one of the things that sets off lots of behaviours at night is interrupted breathing. And we record muscle activity to see when they're moving. And the whole thing in the corner of that red light is because this camera is an infrared camera. So they switch off the light and they think they're in darkness, but actually we can still see what's going on.
And given that there's a camera, does that mean you sit up and watch them all night?
No, so in some sleep laboratories they do that. We keep people under surveillance in case they need any assistance in the night, but usually all of the information is downloaded and scored the next day, and we usually have the answer by lunchtime.
So that quick?
Yeah, it's all processed the next day, so the patients don't have to make more than one trip.
In terms of treatments then, is it more a case of changing your lifestyle rather than medication, or is it often a combination of both until they're better?
So we would always, with any sleep condition, we would start first of all with trying to get people to have the best sleep pattern. So we would always start with those basics, and only if they're unsuccessful then we would escalate to think about medication.
That's Papworth's Dr. Ian Smith, and before him, Karen Slavik-Leonard and her husband, Adam. You can find Karen's blog at Sleep Talkin', that's without a G, sleeptalkinman.blogspot.com.
You're listening to The Naked Scientist with Kat Arney and also with me, Chris Smith. If you'd like to get in touch with us, you can tweet at Naked Scientist. You can find us on Facebook, facebook.com/The Naked Scientist. And you can also email us, the email address chris@thenakedscientist.com.
Now, work, friendships, exercise, parenting, eating, reading, there just aren't enough hours in the day to get all these things done. So many of us find our day-to-day activities creeping into the time when we probably should be tucked up in bed. This begs the question, will there ever be a point in which we can drastically reduce, if not eliminate, the need for human sleep?
Nancy Wessenston is a research psychologist at the Centre for Military Psychiatry and Neuroscience at the Walter Reed Army Institute of Research in Maryland, and her work focuses on ways to fight the effects of sleep deprivation in soldiers. She's with us now. Hello, Nancy.
Good afternoon.
First of all, when you're working with these soldiers, how much sleep might they have to manage on?
So we know that in deployed environments, the soldiers report that they're often getting less than 6 hours of sleep per night. So we're looking at a substantially reduced opportunity to sleep in soldiers in deployed settings.
And what effect does that have on the people when you measure how they perform when they're subject to this sustained loss of sleep?
Right. So when we bring volunteers into the laboratory and we deprive them totally of sleep, which we've done for up to 3 nights in a row, the main characteristic that we see in their performance is their response time to any kind of stimuli is substantially slowed. So what this translates to in the field environment is basically your ability to respond rapidly is degraded.
And do we know why that happens?
Yes, we have some ideas based on brain imaging work. If we sleep-deprived individuals and then we look at the brain activity while they're awake and sleep-deprived, what we see is that glucose utilization, or that is metabolic activity in the brain, is reduced. And those areas of the brain that are more metabolically deactivated by sleep loss, that is the areas of the brain that appear to be particularly susceptible to sleep loss, also turn out to be the areas of the brain that are involved in higher order cognitive processes such as decision making, anticipation, the ability to formulate novel responses, all those kinds of things that we know are important in the operational setting.
Do you think that those areas become less metabolically active as a protective mechanism, that the brain is effectively tired and therefore it turns down the thermostat, if you like, and just ticks along a bit slower in order to limit damage?
That's possible. We don't know the answer to that for certain, but that's definitely a hypothesis that's being investigated.
What about doing something about it? A strong cup of coffee being at the sort of fairly modest end of the scale, there are also now drugs that increasingly students, academics, we've got reports that maybe 1 in 5 academics are taking drugs like modafinil, which apparently boost their cognition but also keep people awake. They can do all-nighters and things and say they get no cognitive, no brain decrement from doing this. What about chemically helping these soldiers?
We can, in fact, use drugs or other naturally occurring substances such as caffeine to temporarily boost mental performance to well-rested levels. Caffeine, for example, a lot of us use caffeine on a daily basis, but caffeine and compounds such as modafinil and dextroamphetamine, they are only temporary patches. Eventually, you do have to make up the sleep that's lost. Now, you don't have to make it up on an hour-by-hour basis. So, for example, if you lose 2 nights of sleep, you do not have to then subsequently sleep an extra 16 hours in addition to your regular sleep to make that up. What happens is that your sleep deepens so that you actually pay off the sleep debt by deepening sleep, but you do have to some extent, also increase the amount of sleep you obtain as well. So there's no free lunch. If you take a substance to temporarily restore performance, you have to pay the price sooner or later.
And is there a price to pay in the long term? Could robbing Peter to pay Paul in this way lead to long-term brain damage?
There's no evidence right now that insufficient sleep causes brain damage. We believe, based on laboratory results, that in the short term, not obtaining sufficient sleep can cause glucose intolerance and things that eventually will lead to type 2 diabetes and so forth. But right now, again, the long-term consequences of insufficient sleep are speculative. It's correlational in nature.
Nancy, thank you very much. Nancy Westonston, she's from the Walter Reed Army Institute of Research. So I'm okay to keep up with the coffee just as long as I do actually pay the sleep debt back at some point. Probably true for you too, Kat.
Absolutely. I run a blog called You Do Too Much and legendarily claim that I never sleep. And we do know that sleep is essential. It does make us feel better, gets rid of those dark circles under our eyes, but its importance does go way beyond that, as we heard from Nancy. It's when our bodies repair damage, renew cells, balance our hormones out, clean out the waste products, and so much more. Beyond that, sleep also helps support several aspects of mental health, brain function, and long-term wellness. But what happens when you don't get enough KIP? Jeffrey Ilef has been tackling just this issue in his lab at the Oregon Health and Science University. He joins us now. Hi, Jeffrey.
Hi, Kat. How are you?
Hi, thanks for coming. Your work focuses on the connection between the lack of sleep and neurodegenerative diseases like Alzheimer's. But can you kind of take us back a few steps and talk about the discovery that you made a couple of years ago about one of the cellular processes that are going on when we sleep?
What we found was that what the brain seemed to be doing when it was going to sleep was that, contrary to what we thought about fluid movement through the brain, which was that there's this fluid that was on the outside of the brain called cerebrospinal fluid. And we thought that that was sort of serving as this cushion. One of the things that we found was that fluid on the outside of the brain, when animals went to sleep, would be recirculating and pumping back through the brain, washing through the spaces between the brain cells and clearing out some of the cellular wastes that build up in the spaces between the cells throughout the waking day.
So it's literally kind of brainwashing at night.
Yeah, but not the sort of brainwashing that happens in a cult, but rather the sort of brainwashing that your brain needs to have happen to function sort of within the very narrow tolerances that neural activity requires.
So there's all this kind of fluid sloshing about our brains. I imagine a bit like a dishwasher or something like that. But what is it clearing out?
We actually don't yet know everything that it's clearing out. So we know that there's a large amount of fluid flushing back through the brain during sleep. We've identified 2 proteins that seem to be cleared by this process. One of those proteins is called amyloid beta, and one is called tau. And both of those proteins are protein species that are known to build up and begin to clump up in the brains of subjects with Alzheimer's disease.
Is that what's responsible for that kind of groggy feeling the next day?
So we don't know yet whether it's those proteins in particular that are what make you feel so crummy the next day. There's certainly biological evidence that those proteins can make neurons function more poorly and sort of not communicate with each other the way they should. However, there's a number of other proteins and chemicals that are probably also being cleared by the same process, not just amyloid beta and not just tau. And whether it's actually one of those proteins or one of those molecules that's the sort of sleep substance, right? The thing that makes you feel more and more tired as the day goes on, or that's the culprit for making you so foggy the next day, we don't know. One possibility that it's all of the above. If it's the spaces between the cells that's the space where the communication between neurons happens. And if that space is becoming sort of dirtier and murkier, then the network properties of the brain itself may be changing. And that may be what's sort of at the root of that murkiness. It's just a degradation in the quality of the environment of the neurons themselves.
And you mentioned that there is this buildup of these neurotoxins if you don't get a good night's sleep. Do we know if sleep deprivation is what's leading to things like Alzheimer's by not washing out these things?
The simple answer is we don't know yet. There's a lot of correlational data that suggests that there may be a connection between the sleep that you get, its duration, its quality, and the dynamics of the buildup of those proteins in the brain. So, for example, if you take a young, healthy person and measure the amyloid beta within their brain during the day and during the night, what you'll see is during the day, the levels of amyloid beta build up. And then when the subject goes to bed and then you test the next morning, you'll find that the levels will have gone down. So levels of amyloid beta are cycling up and down during the day and during the night. A study in the Netherlands actually showed that in those young subjects, if you kept them up all night, the drop in amyloid beta that's supposed to happen during the night doesn't happen, and instead the amyloid beta levels remain high. Now, that's one night of sleep deprivation. On the very far other end of the scale, we find that among patients with mild cognitive impairment, those are patients with a sort of pre-Alzheimer's disease, worsening sleep quality and shortening sleep duration are both associated with the amount of amyloid beta building up in the brain.
If I stay up really late, loads and loads and loads, which I do tend to, and now you've got me worried, am I increasing my risk of developing a condition like Alzheimer's?
The simple answer is that we don't know yet. The data suggests that all of us who sort of burn the candle at both ends, and I'm certainly one of those people as well, we probably should be thinking about not just, what are the consequences of that this week? Am I going to be foggy at my meeting tomorrow? Or am I going to be kind of short with my kids? We should probably start to think about what do our long-term sleep habits, what are their implications for us, in 20 and 30 years, especially when I think most of us are probably planning on living, into our 70s and 80s and 90s now.
It sounds like there's still a lot to discover when it comes to sleep and what's going on in the brain, but The research that you've done suggests that there may at least be some kind of link. It's not clear whether it's chicken or egg yet between a lack of sleep and the build-up of these proteins and neurodegenerative diseases as we get older. And also from talking to some people, I know that there are links between quality of sleep or lack of sleep and psychiatric conditions. There are problems with people with schizophrenia in their sleeping. Do you think that there should be a bit of a wake-up call to the world to say sleep is really important and we need to do more to ensure better sleep?
Yes, I think that's definitely the case. The research, it's still at a very early stage where we're just starting to appreciate these relationships, but we haven't yet figured out which way they go. Is lack of sleep causing these things, or is lack of sleep simply a feature of mental illness or neurodegenerative disease? We'll be figuring that out, we think, in the next 10 years. But I think it does raise sort of a yellow flag or a red flag for us who walk through life chronically sleep deprived, that there may be a price to pay for that eventually, and we need to bear that in mind as we go about our daily lives.
That's definitely something to ponder while we go to bed tonight. Thank you very much. That's Jeffrey Iliff from Oregon Health and Science University. And big thanks to all our other studio guests today. That's David Stilwell, Tim Post and Nancy Wasenston. And finally, for our question of the week,
Daniel Blackwell has been journeying to the land of Nod to find out the answer to this question from listener Alberto.
If you fall asleep and start dreaming, but you dream you're awake, do you still get a good night's sleep?
I spoke to Professor Ian Wallace, psychologist and dream expert.
Dreaming that you are awake is a common experience, and still getting a good night's sleep depends on what type of waking dream you have.
A waking dream? Does that mean we can be awake and asleep at the same time? That sounds like we're moving into the realm of sci-fi.
It is a common misconception that dreaming and waking are completely different states. They can occur at the same time. Examples of this happening are sleep paralysis and lucid dreaming. Dreaming that you are awake can indicate an episode of sleep paralysis where your body is overly fatigued and asleep, but your mind is still actually awake. This usually reflects that you have been experiencing poor quality sleep over a number of days, and so may still wake up feeling tired. It's a pretty common occurrence, and most people will experience it at some point during their life.
Sleep paralysis sounds like a nightmare. Being awake but not able to move, and rather exhausting. Please tell me that the other types of waking dreams are not as tiring.
Dreaming that you are awake can also indicate that you have entered a lucid dream state. This is when you become aware you are dreaming and are able to choose what happens next in the dream. Lucid dreaming is a very relaxing and refreshing dream state, so this can give you a fantastic night's sleep where you wake up feeling re-energized and ready to fully engage with your day ahead.
But wait, I've been conscious the whole time. Surely that's not a good night's sleep. How could I possibly feel energized when I wake up?
You haven't been conscious or unconscious, but conscious and unconscious. So it's not like pulling an all-nighter. A lucid dream enables you to explore creative solutions to potentially stressful situations in your waking life, so that you can quickly resolve them and release any tension that you have been experiencing.
But what about if I've been running around playing football in my dreams? Will I wake up feeling tired compared to if I've dreamt of having a nice relaxing bath?
Getting a good night's sleep does not depend on the content of your dream or how active you are in your dream. It is the quality of the sleep you are having that determines how refreshed you will feel when you wake up.
We can run marathons or climb mountains but wake up refreshed. A dream come true. But how can we be sure to get a good night's rest?
The easiest way to create a restful sleeping environment is to remove all electronic gadgetry from your bedroom and just make it a simple haven for sleep.
That's a change a lot of us will have to sleep on. I hope that will put your mind at rest, Alberto. Next week, we'll be sucking up to some experts to try and answer this question sent in from Paul.
Could vacuum cleaners be fitted to ships to suck up all the plastic? Alternatively, could we use solar-powered floating vacuum cleaners or charged terminals to attract these plastic particles?
If you've got any bright ideas on how we can clean up the plastic rubbish in our oceans, you can email chris@thenakedscientist.com, find us on Facebook, tweet @NakedScientists, or get in the debate on the forum. That's thenakedscientist.com/forum.
And that is it for this week. Thank you very much to Greer Jackson for production. Next week, plastic. According to the United Nations, global plastic consumption has gone from 5.5 million tonnes in the 1950s to 110 million tonnes per year in 2009. So where does all this plastic go when we're done with it? We follow it from the shop shelves to the recycling plant. Join us next week on that journey. The Naked Scientist comes to you from Cambridge University. It's supported by the Wellcome Trust, the STFC and the EPSRC. My name is Chris Smith, and thank you very much for listening. Until next time, goodbye.